Hello, today we are going to create cable that will allow us to connect external battery for the Zero Yeti 400. In my case, it is a 40 amp hour SLA battery. Zero Yeti is a great product because on both sides of the Yeti you are going to find an Anderson power pole plug. Here is a one, but on the other side you are going to find exactly the same port, and they are called chaining port. Those ports are bidirectional. That means you can use them for pulling power into device like inverter, or you can connect them into external battery and expand your capacity. Instead of external battery, it can be also another Zero, and you can interconnect them together. Chaining ports are connected through 50 amp fuse and 10 AWG wire into the internal battery, and they are wired directly, bypassing any electronic circuitry, any protection. So they are directly connected only through a fuse. For my project, I'm going to use 10 AWG wiring. This is exactly the same as inside the Zero, that is protected by a 50 amp fuse. Fuse is used to protect wiring, and because of that, from technical point of view, I would not need to put an external fuse. If there will be any current higher than 50 amp, which those wiring is rated, the internal fuse is going to be burned. So from technical reason, in stationary application, you could bypass that fuse and your safety should not be compromised. In my case, that battery is going to be moving around. For example, going to put it in a car trunk. So I'm going to introduce a fuse. That fuse is going to be very close to the battery terminal. That way, if this wire is going to be pinched by a trunk, for example, and it will create a dead short here, the fuse is going to be blown. On some videos I saw people adding inline fuse like at the end of the wire, and this is a very bad situation, because if you short circuit them after the fuse, that it's going to be blown. But if that's going to be in car, you snap that with a metal thing, pinch it, the insulation is going to be broken. There is nothing to protect the wire. Fuse is always used for protecting wires, so it should be as close to the source as possible. So any short, no matter on what length, is going to trigger it. This is fuse that I'm going to be using. It came straight from China in that very nice blog. You are going to be opening here, and here is your 50 amp fuse link. You are going to put your wire lugs here, and it is a very nice and very beefy. I'm going to put it close here. I'm going to also need a wire terminals, and one of them most likely going to be fitting both my battery and the terminal lug on the fuse. We are going to end this project by adding a Anderson power pole terminal, and it's going to be fit into the Zero. All of this should make it not only safe but pleasant to look. So let's go and start our work. We are going to start from finding a terminal lug that is going to fit both of cable and also this terminal, and it looks like a perfect match. This is what we are going to be using, and it will make a lot of sense. So this is a perfect fit. Those terminals most likely are designed to be crimped, but I do not have a proper crimper, so I'm going to solder it. I'm going to make this wire a little bit shorter to get a nicer spacing. I'm going to remove the insulation and let's see whether it have a correct size. And looks like it fit perfectly. I'm going to start from thinning that wire. That way it's going to be nicely mounted. I've got my RF soldering station, so it should be pretty good. Just like that. Now I'm going to supply heat and pre-fill that little bit. So let me just add it to the side, and I'm going to be adding my soldering inside. So I'm going to nicely filling that. It's nicely filled, and now I'm going to stuff it in. And remove the heat and wait a couple of seconds, and we should have a great connection. I can see a portion of the solder flowing out. We've got a great terminal without a crimper. So let me repeat that process. I'm not doing that at once because I could stuff it here, but then the insulation is most likely going to be melted. So I would like to have the solder inside the terminal completely melted. And now I just stuff it in, and as you can see, it is nicely wet. It's wet, I'm releasing it, and they are nicely cooling down, and we are going to get a perfect connection. You can see the solder flowing out, and it's done. The first part is over. Now we are going to put a heat shrink. Let me nicely heat shrink it. Let's see how the fuse fit into our new wire. Let me undo that. I can see that we've got a protection against undoing, and that spring washer. So we go like this, maybe upside down, and looks like it's going to fit beautiful. We are going to get a really beautiful and professional looking job. Just take a look how nice it's going to present. And we've got our beautiful job. That looks perfect and without a crimper. Let me add a heat shrink and we are going to see the final result. Let's add a nice heat shrink to make it look a little bit more professional and prevent against accidental short. I can see that we are going to get a beautiful job. That's going to be working like a charm. This is looking beautiful. Let's see, does it going to catch? And yes, it does. We've got a perfect looking fuse and we are ready to stack it onto the battery. But we'd have to hold on for a moment because we need also a Anderson power pole for our actual Go Zero Yeti connector. make a hole for our sleeve, because we don't want to forget that. Very nicely. Maybe even a little bit bigger, but no, that will be okay. Let's clean the wire. Let me solder the terminal. I know it should be crimped, but I do not have a proper crimper, and for one job I'm not going to purchase it. So I'm fully aware that this is not how you do it. I'm fully aware that this is not a professional job. Terminal, so the positive we go like this, the negative we go like that. So we have to join them together, and you can slide them. And the catch is going to be pushing that metal element that you can see, like the hand is going to grab it. So if it go like that, then the hand go like this and it will push it. And we have to just stuff it in. And you can see that it catch it and it push it downward, and now you cannot take it out. So just the tip, and it should be good enough. It don't look beautiful. The metal element is there. The catching hand go like this, and we slide it in. Maybe I will cut that excess. Let's try again. And this time it nicely catch that. So this is a proper done plug. Just for reference, here is how looking undone. That metal thing is free. I'm going to be adding a glue compound. Just like that. I'm going to fill it, and then I will nicely put it over. Now it will not come out. It looks absolutely beautiful. So we've got the Anderson power pole on one end. We've got a fuse, 50 amp, and the terminal lugs. We are ready to put everything together. We are going to start from the battery. I'm going to attach the positive lead. And very shortly we are going to get a beautiful job done. Because we are dealing with serious amount of amp, before plug it in, I'm going to make sure that the polarity is correct. And yes, it does. Make sure your both batteries are in kind of similar state of charge, because we are going to have a equalization current flowing. So let me try to plug it in, and we are connected. We are being chained, and looks like we need to make some testing. Time to check whether our system is working, and we are going to be using our inverter with this clamp meter. So let me go into a 20 amp value. Let's go into the DC, let's zero it, and we are going to see is there any equalization current, and looks like we've got something. Let's turn on the inverter, and we should start seeing that we are taking about 1 amp from that secondary battery, and I'm going to turn on the lamp. And as you can see, we are pulling 3.6 amp from the external battery. So everything is working just fine. And this is the response that we would like to see. So our chaining system is working perfectly. Now the real test. I'm going to plug charger, and we should start seeing the different sign because the current will be flowing backward. So I'm plugging charger, and we can see over 2 amp flowing into that battery. We've got a 3 amp going there. So as you can see, we've got a beautiful job. This is how you do it. We've got a safety fuse, everything nice, and we expand our capacity. So thank you very much for watching. I hope you find that interesting. See you next time, and bye bye.